Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0532 indicates a low voltage condition in the AC pressure sensor circuit for the Honda Accord models produced between 2008 and 2012. The AC pressure sensor plays an essential role in the air conditioning system by monitoring the refrigerant pressure and providing feedback to the engine control module, ECM, or powertrain control module, PCM. This information is crucial for the proper functioning of the air conditioning system as it helps regulate performance and ensures that it operates within safe parameters. In this trouble code, low voltage suggests that the sensor is detecting a voltage reading of 0.24 volts or less, which is below the normal operating range expected from the AC pressure sensor. Before starting any diagnostic steps, you should record all freeze frame data and any available snapshots to gain insight into vehicle performance prior to the error occurring. This can provide valuable context when diagnosing issues. Familiarizing yourself with the general troubleshooting process ensures a systematic approach to identifying and resolving the underlying issue. The AC pressure sensor is integral to the overall functionality of the air conditioning system in the Honda Accord. It measures the pressure of the refrigerant circulating through the system and relays this information to the ECM or PCM. Its role is critical since it helps optimize air conditioning performance and protects the system from damage due to low refrigerant levels. The sensor is typically located near the AC compressor, which is responsible for compressing the refrigerant and sending it throughout the system. If the sensor detects pressures that are out of the expected range, it can trigger warning lights or turn off the system to prevent further damage. Therefore, ensuring the sensor functions correctly is vital for operational efficiency and system longevity. By understanding the location and role of this component, technicians are better equipped to diagnose issues related to DTC P0532. Several potential causes can lead to the triggering of DTC P0532, and understanding these enables more targeted troubleshooting. A faulty AC pressure sensor is the most straightforward explanation. If the sensor malfunctions, it may provide incorrect voltage readings to the ECM or PCM. Wiring issues, such as frayed or damaged wires, can create interruptions in the circuit, leading to a failure in voltage transmission. Poor connections at the AC pressure sensor or ECM/PCM can also contribute to low voltage conditions. Corrosion or loose terminals can hinder proper electrical flow. Lastly, a defective ECM or PCM, although less common, can misinterpret the signals sent by the AC pressure sensor, yielding erroneous results. Elimination of these possible causes involves systematic checks of each component. When DTC P0532 is triggered, several symptoms may become apparent while operating the Honda Accord. The most common and noticeable symptom is that the air conditioning may not function correctly, leading to inadequate cooling inside the vehicle. This can result in an uncomfortable driving experience, especially during hot weather conditions. The check engine light may illuminate on the dashboard, prompting the driver to investigate further. Additionally, some users may experience erratic AC performance, where the system may intermittently engage or struggle to maintain desired temperatures. A low refrigerant indicator could also appear due to the sensor's malfunctioning readings, leading the driver to believe there is a refrigerant leak, even when the refrigerant levels are adequate. Recognizing these symptoms aids in quicker diagnosis and repair. The first troubleshooting step in addressing DTC P0532 involves preparing the vehicle for diagnosis. Start by ensuring that the engine is running and allowed to idle to achieve normal operating conditions. Once the engine is stabilized, activate the blower switch so that the cabin fan operates at its designated speed, facilitating the proper functioning of the AC system. Next, ensure the AC switch is turned on, which is necessary to allow the air conditioning system to engage and begin operating. Finally, utilize the Honda Diagnostic System, HDS, to check the readings from the AC pressure sensor. A reading of approximately 0.24 volts or less at this stage would indicate trouble, while a higher reading suggests that the system is functioning correctly for the time being. This stage sets the groundwork for further investigation. In the second step, the goal is to assess the data captured during the first step. Once the AC switch is engaged and readings are obtained, verify if the AC pressure sensor shows a voltage of approximately 0.24 volts or less. If this condition is present, it signals a possible fault in the sensor or circuit, prompting the technician to proceed to the next steps in the diagnostics. Alternatively, if the voltages fall within normal ranges, consider this as an intermittent failure. Regularly monitor the system for poor connections or loose terminals at both the AC pressure sensor and the ECM or PCM. This approach not only assists in identifying issues, but also enhances the overall reliability of the air conditioning system. The third step involves querying the AC pressure sensor under controlled conditions. Begin by turning the ignition switch to the lock position, ensuring all vehicle electronics are powered down. This step is crucial for safely disconnecting the AC pressure sensor. Proceed to disconnect the AC pressure sensor 3P connector, ensuring that the connection is not damaged during disconnection. Once the sensor is disconnected, turn the ignition switch to the on position 2, allowing the diagnostic system to remain operational. Check the AC pressure sensor data again using the HDS. If you find a similar voltage reading of about 0.24 volts or less, this indicates an issue that warrants additional troubleshooting steps, while higher data readings may suggest other areas of concern within the vehicle's electrical system. This step focuses on further diagnosis of the AC pressure sensor connection to the power supply. First, ensure that the ignition switch is still in the on position. Utilizing a multimeter, measure the voltage between AC pressure sensor 3P connector terminals number 1 and number 3, which corresponds to the sensor's power input and ground connections. If the voltage observed measures around 5 volts, this indicates a proper power supply to the sensor. And the problem might lie either within the sensor itself or in its wiring harness. Should the voltage be lower than expected, it suggests a fault in the wiring that needs correction for proper functionality. This careful scrutiny is essential in accurately diagnosing DTC P0532 to rectify the AC system issues. Step 5 requires specific preparations to check continuity within the circuit. Begin by turning the ignition switch to the lock position to ensure security while working on the sensor. Once in lock, use the HDS to jump the SCS line, which maximizes diagnostic capabilities during the subsequent tests. Disconnect the ECM/PCM connector A49P carefully to avoid damage to the pins. By preparing the system in this way, technicians can better assess the electrical pathways connecting the AC pressure sensor to the ECM. Ensuring correct ground connections is vital for proper performance. This step establishes a solid pathway for verifying whether signal and power lines are intact between the AC pressure sensor and the vehicle's control modules. After completing all necessary repairs based on diagnostic findings from steps 1 through 5, the final repair verification process ensures that the AC system operates as intended. Start by reconnecting all previously disconnected connectors, ensuring that everything is securely fitted to prevent future issues. Following this, test the AC system to verify that it cools correctly, checking for any unusual noises, performance drops, or error codes. Clear the DTC codes from the ECM using the HDS to reset the system and remove any previous fault indicators. Finally, conduct a thorough road test, monitoring the AC performance under various environmental conditions to ensure that the issue has been successfully resolved. This step is critical to confirm the effectiveness of the repairs and restore normal functionality. To prevent the recurrence of issues associated with DTC P0532, it is highly beneficial to establish a routine of preventive maintenance for the AC system. Regularly checking the air conditioning system will help identify issues before they escalate, ensuring timely interventions when necessary. Inspecting wiring and connector integrity should be part of regular maintenance to detect wear or corrosion early, which can cause future failures or erroneous sensor readings. Using high-quality refrigerant compliant with manufacturer specifications can also play a significant role in maintaining optimal performance standards. Finally, ensuring that the ECM/PCM software is up to date can enhance the system's ability to diagnose and adapt to changes in the air conditioning setup. By adhering to a proactive maintenance schedule, overall vehicle reliability can be greatly improved. In summary, a comprehensive understanding of DTC P0532 can significantly enhance the efficiency of troubleshooting efforts related to the AC system in the Honda Accord from 2008 to 2012. By following a structured diagnostic process that includes checking sensor readings, inspecting circuits, and performing continuity tests, technicians can accurately identify and resolve the underlying issues. Incorporating a regimen of preventive maintenance ensures better performance and reduces the likelihood of future problems arising from sensor or electrical failures. Lastly, confirming repairs through thorough testing and evaluations ensures that the vehicle's AC system functions correctly post-repair. By employing these methods, both vehicle longevity and driver satisfaction can be achieved. Please like and subscribe to the channel. See you next time!